Hi there, beautiful people. I'm Chris Jones. I'm talking for Meet the Scientists on COP26.tv. I'm very, very proud and pleased to be interviewing Professor David Hanna from the University of Birmingham, and he's a professor of hydrology at the School of Geography, Earth and Environmental Sciences, UNESCO Chair in Water Sciences, and Reuters Top 1,000 Climate Scientists. So quite a good person to be talking to, particularly as sort of COP26 draws to a close. So I've got some really interesting questions, and hopefully we're gonna learn quite a lot as well. Welcome, David. How are you doing today?
Very well. Good afternoon, Chris. Nice to meet you.
Nice to meet you too. So I generally try and steam straight in with a question about, what do you do as an overview? So what professor of hydrology, what does that mean to the sort of general public?
Yeah. So yes, as you say, I'm a professor of hydrology and also UNESCO chair in water sciences at the University of Birmingham. And I do research to understand how the water cycle works and also understand hydrological events, floods, droughts, and water quality extremes, and also understand water-related impacts on ecosystems, people, under climate and other drivers of change. Within that, more specifically, I work on three interdisciplinary problems. The first of which is developing new knowledge about some of the climate drivers and also how hydrology responds and habitats change in high mountain and high latitude environments, so Arctic and alpine environments. The work there is around trying to understand water security and changes in biodiversity in those systems. I also work on very large scale hydrology, trying to understand the links, particularly between river flow and climate and land use change. That's all about figuring out, using models and also observations, how interconnected the water cycle is, how it all fits together at regional to the whole globe scale. And finally, I work on trying to unravel what drives river temperature dynamics. So how rivers heat up and cool down. River temperature is really important for all the physical, chemical and biological processes in river systems. And in that space, we also try and understand what adaptation strategy we can undertake under climate change to reduce high temperature extremes that are damaging to aquatic organisms, but also for how water is used by people. So it's all in the space of understanding our water world, dealing with wicked water problems, which are often the result of lack of data and lack of knowledge, as well as contested human needs.
Okay, so well, I guess the key sort of drivers that behind COP26 TV are kind of looking at climate change, but also looking at the effect on the peoples of the world, and in particular sort of like the global south. So I'd be quite interested to hear about how your research and the data is looking at any changes in the water cycle. I mean, are there any changes that you're noticing for a start?
Yeah, I mean, absolutely. There are definitely changes on the water cycle as a result of anthropogenic climate change. I think we're in a position now where the scientific community's agreed that the Earth's water cycle is changing, and there are widespread patterns that can be associated with climate change in water vapor, in clouds, in precipitation, in what we call runoff patterns, so the water that we see in rivers, but also frozen water in terms of snow and ice. Must remember that that's water too, and also water in the ground, in the subsurface groundwater. The water cycle, I would argue, is really what you would call the climate connector, because most people feel the impacts of climate change through the water cycle, through floods, droughts, changes in water quality, and of course, changes in water security and threats to livelihoods. As you might be aware, as the atmosphere warms, particularly the lower atmosphere warms, the amount of evaporation that can occur increases. And as a result, the amount of water cycling as part of the water cycle increases. And as a result of that higher atmospheric moisture, it's got to rain out at some point. So our precipitation regimes have become more intense and extreme over land. And also because of the warmer temperatures, a lot of that precipitation falls as rain rather than snow. And in parts of the northern hemisphere, as temperatures rise, there's been a shift in the river flow regimes in terms of the amount of rainfall that occurs compared to snowfall, but also snow melting earlier and glaciers starting to shrink. And as a result of that, what we find is that often we have now peaks in river flow earlier in the summer melt season and quite significant low flow periods as we get into late autumn and winter. And they're often the times at which people have the highest demands for water in that summer and late into autumn period, so in terms of freshwater resources. So there are significant changes occurring in the hydrological cycle. We done quite a lot of work in the Himalayas, also in the Andes, looking at how these changes have had impacts upon different communities there in terms of water availability and their ability to use ecosystem services. Be very happy to talk more about that.
Yeah, absolutely. I was just going to ask, sort of what locations is your research focusing on? So I mean, like how do these communities, for example, particularly in the Andes, how do they interact with the glaciers and the glacial runoff? Like how do they use it?
Yeah. So we've had, and we've got a recent ongoing project working in Peru. We've worked there for some time now with colleagues at Imperial College London, but also really importantly, local partners, Condescent in Peru and local communities. We've done the same thing actually in the Himalayas, current projects working in Nepal. What's really important to recognize there is that many of the livelihoods are very much intertwined with what we would call water-dependent ecosystem services. So all the things that water does for us, so the water that's available for different types of uses, particularly agriculture. And if we think about Nepal rather than Peru, 90% of people there are on subsistence agriculture. So what that means is they use that water to grow food for their families. Yeah. But if they could use that water in a different way, and we're thinking about this in the context also of a changing and more dynamic climate, if they can use that water in a different way, they may be able to grow a crop of apples, make some cheese, grow an extra quantity of rice and sell that in the local bazaar to make money and help in terms of poverty alleviation. So what we've been doing in both Peru and Nepal is working with the local communities, using their indigenous local knowledge to implement low-cost environmental sensors. So these would be sensors for things like river flow, rainfall, for a few hundreds of dollars. We're able to distribute them around the river basins, working with the communities, and then provide those data to the communities, but embed them in the data collection process through participatory monitoring, or what some people might call citizen science, and have them.
What was that last bit? Sorry.
What people might call citizen science. So people becoming scientists, collecting the data themselves. They then collect those data. We then help them to process that information and use that information about their water environment to make different choices in terms of decision making. So we call that adaptive governance. So as people are able to update their knowledge of the environment, they're able to make different choices about what they do with that water. And by decentralizing that process, that empowers them, that gets them trust in the scientific information and allows them to action it, to do things with it, to change the way in which they might use some of the water dependent ecosystem services in the hope that that may help them have better livelihoods.
I did an interview recently with someone working in Africa, and they were looking at flood mitigation strategies, and the way that they were communicating with the various communities, because they're obviously quite spread out, working in Uganda and Kenya, they were having to use like local radios to sort of communicate out the messages. I mean, how was the communication with your sort of project?
Yeah, I mean that's a great question. I mean, communication is key, because it's one thing to have information. The second thing is to be able to use it. So we have learned that working with social science colleagues is really important, and we've also recognised that some of the non-technical aspects of developing some of these sensors are actually incredibly important. So, what do you do with the information? How do you get it to people? There's work we've been doing on how we visualize things. So if you provide many communities with bar charts and the like, that's not very helpful. But if you offer them something that looks like a fuel gauge between empty and full, that's perhaps more sort of interpretable. We have used local radio, and we've got to also be aware that in many of these environments, people aren't as literate So it may be the fact that there's been a generational skip, that people may have a smartphone, so they've gone all the way from having no connectivity to having a smartphone. But some of their communication skills are not as refined, but they're still very much able to use that. Also very notable is that many of the people that know a lot of things about the water environment are the women within villages, but they don't necessarily have access to the technology and to the tools. So we've got to be very careful that in terms of the way you provide information, that it's accessible and decentralized and available, and doesn't reinforce power elites or provide people with data they can make choices around that either they don't understand or they use for their own benefit. So it's very, very important, Chris, to think through those important things about how you communicate, who you communicate with, and whether you're getting that to the people that can action it in a way that's actually going to help in terms of providing more of an equality of opportunities for people.
I mean, there's, with regard to sort of like these communities are sort of relying on glaciers and things like that, aren't they?
In Nepal, yes.
And yeah.
Yeah.
What about the Andes?
In Peru too. So what we're doing in the current project in Peru is that as the glaciers are shrinking and melting there, we also have that. So in terms of water being available for people, what glaciers do is they act like natural reservoirs. So they store water in the winter season, and they release that water in the summer season, in a very simple terms. So they act as a natural reservoir. And as those glaciers shrink, the size of that reservoir declines. And as I said earlier, you often get higher flows earlier in the season as the snow melts, and as the glaciers are smaller, if you get into the late summer and autumn, there's less water available. But what we've been doing in Peru is thinking about the potential of nature-based solutions and what we might call natural capital there, other ways of storing and releasing water. So in Peru, there's high altitude wetlands called the bofedales, which are big wetland areas. People might have seen in nature documentaries, et cetera, things like the altiplano, so high altitude wetland systems. They may act like natural sponges, like glaciers do, in terms of storing and releasing water, but in a different way. So we're very interested to find out that as the climate changes, can these high altitude wetlands have that storage and release mechanism in the same ways that the glaciers did to provide water later in the season for people? I mean, the issues people have around water are too much, too little, or too polluted. So in relation to these glacial catchments, it's often the too much early in the season, and later in the season, too little as the reservoirs, as glaciers shrink, the higher altitudes start to run dry. So the potential of the environment itself providing other ways of storing and releasing water to spread that water out and make it more available is something that we're doing research actively on at the moment. Come back in a couple of years for answers on that one, I think.